Deep beneath our feet lie ancient chambers that defy everything we think we know about early human tools and technology. This video explores the profound mystery of subterranean chambers built far deeper than ancient tools should allow. We will journey to hidden cities carved into the rock of Turkey and navigate the sacred, echoing halls beneath the Maltese islands. You will discover evidence that challenges our timeline of human innovation, revealing a past far more complex and capable than textbooks often describe. How did people with simple copper chisels and stone hammers engineer vast, stable worlds thousands of feet underground? By the end of this exploration, you will see human history in a completely new light, armed with a new appreciation for our ancestors' forgotten potential. What does it truly mean to build something that lasts for millennia? The heart of this mystery lies not in the existence of these chambers, but in their impossible engineering. We are not talking about naturally occurring caves that were later expanded. These are vast, deliberate complexes, planned and executed with a foresight that still baffles experts today. Picture a city carved entirely from the living rock, hundreds of feet beneath the surface. It is a world of interconnected halls, staircases that spiral into the deep, and rooms with ceilings so high a modern house could fit inside. But what truly separates these spaces from crude shelters are the features we associate with sophisticated architecture. Archaeologists like Dr. Emily Carter point to intricate ventilation shafts that brought fresh air to the lowest levels, a critical necessity for survival. They identify carefully carved wells that tapped into underground water sources, providing a permanent supply. The walls themselves are often adorned with precise carvings and symbols, evidence of a deep cultural or spiritual purpose. This was not mere digging, it was a form of underground urban planning. The logistical challenge is almost beyond comprehension. Workers had to excavate through incredibly hard rock, like granite or basalt, using what we believe were simple copper chisels and stone hammers. Think about the sheer volume of material they had to remove. We are talking about thousands upon thousands of tons of solid stone. How did they transport this debris up from such profound depths? Even more critically, how did they ensure the structural integrity of these caverns, preventing collapses over centuries? And how did they manage to breathe while working in such confined, deep spaces without the air turning toxic? These are not minor questions. They strike at the very core of our understanding of ancient innovation. The tools we have found in the archaeological record simply do not seem equal to the task that was accomplished. This glaring gap between the evidence of their methods and the magnificence of their results is what pulls us deeper into the story, guiding us to the very places where this ancient mystery is set in stone. To understand the scale of this challenge, we must step inside one of its most breathtaking examples. Deep within the Cappadocia region of Turkey, the Derinkuyu underground city descends nearly 300 feet into the earth. This was not a simple cave system, but a vertical metropolis carved with astonishing intention. Its 18 explored levels contained everything needed for a community to endure, from living quarters and churches to stables for livestock and even communal kitchens. Enormous circular stone doors, each weighing several hundred pounds, could be rolled across passageways to seal off entire sections from the inside. This was a place designed for long-term security, a true refuge hidden from the world above. The engineering that made this possible is where the mystery truly deepens. Ventilation shafts drilled with remarkable precision ran from the deepest chambers all the way to the surface, ensuring a constant supply of fresh air for thousands of people. Wells tapped directly into the underground water table, providing a self-sufficient source. The builders did not just hack randomly at the rock, they demonstrated a profound understanding of their medium. They intentionally carved rooms and tunnels within a single, stable layer of volcanic tuff, a rock soft enough to work yet strong enough to hold its shape for millennia. The alignment of the corridors and the placement of support columns show a planned approach to managing stress and preventing collapse. Yet the tools ascribed to its original builders, likely the Phrygians or even the earlier Hittites around 2,800 years ago, were fundamentally simple, rock-cut picks and chisels. With such basic implements, the logistical feat becomes almost unimaginable. Excavating enough solid rock to create space for 20,000 individuals, plus their animals and food stores, represents the removal of hundreds of thousands of tons of material. How was this debris hauled up from such profound depths? How did they illuminate the Stygian darkness to work with such consistent precision? The existence of Derinkuyu stands as a silent, monumental question to our conventional history, compelling us to look for echoes of its impossible construction in other parts of the world. Far from the sun-baked plains of Turkey, another underground world whispers an even older secret. On the Mediterranean island of Malta, the Hypogeum of Hal Saflieni descends over 30 feet into the soft limestone. This is not a city for the living, but a vast, multi-level sanctuary for the departed, a necropolis and temple complex carved over 5,000 years ago. Its 3 distinct levels were hewn over centuries, a labyrinth of halls, chambers, and burial niches that feel both solemn and strangely alive. To walk its corridors is to move through a sacred architecture designed for a journey beyond the visible world. The sheer depth is remarkable, but it is the Hypogeum's voice that truly defies explanation. Specific chambers, known as oracle rooms, possess an extraordinary acoustic property. A single word spoken in a low tone resonates through the stone, amplified and distorted into a deep, pervasive echo that seems to fill the entire space. This is not a random quirk of the rock. Acoustic researchers like Dr. Linda Engi suggest this sound engineering was entirely intentional, a built-in feature designed to transform the human voice into something otherworldly for rituals and ceremonies. The implications are profound. The builders, using nothing more than antlers and stone tools, were not just digging, they were sculpting sound itself. They carved the walls with such smooth, flowing precision and adorned them with intricate spiral motifs that the rock appears to have been worked with a softness we cannot replicate with their presumed tools. How did a Neolithic culture, millennia before the pyramids, achieve such acoustic precision and structural stability? The mystery of the Hypogeum pushes us to consider that their greatest tools may not have been physical, but spiritual. A deep-seated knowledge and patience that allowed them to listen to the stone and shape both it and the air within it into a form of sacred technology. This quest for understanding beneath the earth does not end in the Mediterranean, however. It calls us to look even further, to a continent where another impossible excavation challenges our entire timeline of human innovation. The impulse to carve safety from the earth was a global phenomenon, a testament to human resilience in the face of recurring hardship. In the chalky hills of northern France, the underground city of Naours presents a different kind of marvel, one born not from spiritual ceremony but from sheer practical necessity. This sprawling complex, a labyrinth of 300 rooms spread across multiple levels, plunges more than 100 feet into the soft bedrock. Its story began in the 3rd century as a Roman quarry, a place to extract building stone, but over generations it was transformed into something far more ambitious, a subterranean refuge for entire communities fleeing the conflicts that swept across the region. Here you find not oracle chambers, but streets, stables, and even chapels, all meticulously carved from the chalk with simple picks and shovels. The sheer scale of the excavation is what stops you. To create this hidden world, its builders had to remove an estimated 200,000 cubic meters of material. That is a volume of rock and earth equivalent to a small mountain. Just think of the countless journeys up and down, hauling basket after basket of rubble to the surface, all by hand, over what must have been many lifetimes. The logistical challenge is staggering, but perhaps even more impressive is the engineering foresight. The ceilings were carefully arched for stability, preventing collapses over centuries. Entrances were cunningly hidden, ensuring the safety of those inside. This was not a haphazard digging project. It was a masterclass in applied subterranean architecture, a planned and durable sanctuary. Why would a community pour so much collective effort and time into a place they hoped never to have to use? The answer lies in the value of a guaranteed refuge, a secure space that could shelter thousands of people and their livestock through periods of immense danger. Naours demonstrates that the drive to build deep was often a matter of survival, a practical solution to the recurring threat of conflict. Yet, the methods they used with such simple tools to achieve such stable, vast, and enduring spaces continue to challenge our assumptions, pushing us to ask if we have underestimated the accumulated knowledge of past builders. This practical mastery of the underground world finds an even more extreme expression far across the globe, where an ancient civilization chose to build not just for safety, but for eternity, in a place where the very rock defies conventional tools. Yet another testament to this deep human drive lies beneath the rolling hills of Poland. The Wieliczka salt mine is a world turned inside out, a kingdom of salt that plunges over 1,000 feet into the earth. Its story began in the 13th century when miners first broke through the surface to uncover a precious crystalline resource. With only basic hand tools, wooden supports, and the strength of their own bodies, they began a descent that would span generations. The initial achievement is staggering to consider. Men carving deep shafts and vast chambers through solid salt rock without the safety equipment or machinery we take for granted today. Each swing of a pick was a gamble against the immense pressure of the earth above, a test of their understanding of the rock's integrity. How did they know where to dig, how to brace the ceilings, how to navigate the darkness and the ever-present risk of collapse? Their success speaks to a hard-won, generational knowledge of geology passed from one miner to the next. But then, something even more remarkable happened. Deep within this functional, industrial space, artistry began to bloom. The miners did not just extract salt, they transformed their workplace. They carved elaborate chapels with altars and pews, sculpted lifelike statues of historical and religious figures, and even fashioned breathtaking chandeliers, all from the very salt that surrounded them. These were not crude markings, but works of profound craftsmanship created in a world of perpetual night. What inspires people to create such beauty in a place of such grueling, dangerous labor? The answer may lie in the human spirit's need to leave a mark, to elevate utility into meaning. The mine became a cathedral to both faith and toil, a place where the practical need for safety and stability was seamlessly blended with a deep artistic expression. This fusion of sheer physical effort and spiritual creativity challenges our narrow view of medieval capabilities, suggesting that the drive to build profound and beautiful things underground is a fundamental part of our story, one that leads us to a final, overarching question about the knowledge that made all of this possible. The challenge of building deep was not confined to ancient history or distant continents. In the dense jungles of Vietnam, a vast and intricate tunnel network reveals how ancient traditions of subterranean engineering were adapted for a modern conflict. The Kai tunnels stretch for over 75 miles, a hidden world of narrow passageways, some descending 30 feet beneath the Earth's surface. While they gained fame during the Vietnam War, their construction methods were not invented in the 20th century. They drew upon a deep well of ancestral knowledge, a Vietnamese tradition of tunneling and underground habitation that dates back centuries. The builders of the 1960s used simple hand tools, little more than hoes and baskets, to accomplish a feat of logistics that still astonishes military historians. They carved out living quarters, storage rooms, command centers, and even field hospitals, all concealed from the world above. Their success hinged on a profound understanding of the local soil, a specific type of clay that was soft enough to dig yet held its shape with remarkable stability, preventing collapses even under the stress of heavy foot traffic and distant explosions. Ingenious trapdoors camouflaged with leaves and dirt made entrances virtually invisible. How did this knowledge persist through generations? It speaks to a cultural memory, a passed-down expertise in how to live within the earth, a skill set that proved vital during a time of immense hardship. The Kai tunnels stand as a powerful reminder that the ability to build profound structures underground is a recurring theme in our species' story. From the sacred halls of Malta to the refuge cities of Turkey and the survival networks of Vietnam, we see a persistent pattern. This pattern forces a difficult question. Could our standard historical timeline, which assumes a steady, linear progression of technology, be missing a crucial chapter? The tools we find in the archaeological record, the simple chisels and stone picks, seem utterly inadequate for the monumental tasks we see accomplished. This glaring disconnect invites us to reconsider the very nature of the tools our ancestors might have possessed. Perhaps their greatest asset was not a physical object, but something far more valuable and elusive, a forgotten science of the earth itself. The reality of these tools presents a stark contradiction. A copper chisel, one of the hardest metals available to many early builders, is remarkably soft against stone. When struck against granite or basalt, a copper edge would deform, dulling almost immediately. The work would not be a steady chipping away, but a constant cycle of hammering, blunting, and resharpening. Imagine the sheer number of chisels required, the endless maintenance, the mountains of stone dust created by such a painstaking process. Archaeologist Dr. James Harrell has conducted experiments recreating these conditions, demonstrating that even with stronger bronze tools, the excavation of deep, precise chambers would have been an excruciatingly slow endeavor, demanding millions of man-hours for a single complex. The logistical weight becomes almost unbearable to consider. Yet we are faced with the physical evidence of these spaces, their walls often showing clean, deliberate cuts and smooth finishes that speak of control and efficiency. This is the core of the tool paradox. The implements we have found in the archaeological record seem fundamentally mismatched with the monumental accomplishments we see carved in stone. How do you explain a masterfully detailed sculpture when the only tools we can prove were available are blunt instruments? This gap forces a difficult but fascinating question. Were there other tools now lost to time that these builders possessed? Some researchers point to the possibility of forgotten alloys, metal mixtures that achieved a hardness we do not typically associate with their era. Perhaps they employed techniques we have yet to rediscover, methods that involved softening the stone itself with heat or chemical solutions, making it more malleable. Or maybe their greatest advantage was not a superior tool, but a superior understanding of the rock's natural fracture lines, a geological wisdom that allowed them to work with the stone, not just against it. This paradox pushes us to look beyond the simple inventory of hammers and chisels, and to consider the intellectual toolkit these ancient engineers must have commanded. Their true innovation may have been a deep, patient science of the earth, a knowledge that turned an impossible task into a lasting legacy. The paradox of soft tools shaping hard stone leads us to one of the most compelling theories, a method that turns heat and water into a geological chisel. This technique, known as fire setting, involved building intense fires directly against the rock face. Once the stone was glowing hot, workers would douse it with cold water. The sudden, violent temperature change created thermal shock, causing the rock to crack and spall, becoming brittle and far easier to break apart with even simple stone hammers. We have tangible evidence for this practice. In the ancient copper mines of Timna, Israel, dating back over 6,000 years, archaeologists find walls blackened with soot and rock surfaces scarred by the distinctive cracking of thermal stress. This was not a random discovery, but a controlled technological process. It elegantly explains how cultures with access only to copper or stone could quarry incredibly hard materials like granite. Yet, applying this method deep underground presents its own labyrinth of dangers. In a confined space like a narrow tunnel hundreds of feet down, the risks were immense. Uncontrolled fires could consume the precious oxygen, while the resulting smoke and fumes would quickly turn the air toxic. There was also the constant threat of triggering a wider collapse, as the intense heat could unpredictably weaken the surrounding rock structure. So while fire setting offers a plausible key to the tool paradox, it raises new questions about the level of control these ancient engineers possessed. Could this risky, labor-intensive process truly account for the smooth, precise walls and vast, stable halls of a place like Derinkuyu? It suggests a society with not just brute strength, but with specialized knowledge, individuals who understood the properties of their local stone, the dynamics of airflow, and the precise application of heat. This points to a level of organization far beyond simple survival, hinting at a forgotten school of subterranean engineering. Perhaps their most brilliant strategy was to work in partnership with the earth itself. A compelling perspective suggests that many of these deep chambers did not begin as raw excavations, but as natural caves, fissures, or voids that were intelligently identified and then masterfully expanded. Instead of fighting the rock from the very beginning, ancient engineers may have first sought out the perfect geological canvas. In Cappadocia, for instance, the soft volcanic tuff is riddled with natural formations created by ancient gas bubbles and water flow. Early builders would have explored these hollows, selecting those with the most promising structure and stability, then carefully carving them outward to create interconnected rooms and tunnels. This approach dramatically reduced the sheer volume of rock that needed to be removed, turning an impossible construction project into a manageable renovation of the landscape. But their partnership with nature may have gone even deeper. Geologists studying certain subterranean sites have identified telltale signs of water erosion on the walls and ceilings. Patterns that suggest flowing water helped shape these spaces long before human hands ever touched them. It raises a fascinating possibility. Did these early builders harness the power of water itself, diverting natural underground streams over long periods to gradually wear down and soften the hardest stone, creating the basic forms they would later refine? This shifts the entire mystery. The question is no longer just how they dug so deep with simple tools, but how they learned to read the land so expertly. How did they develop such a profound understanding of hydrology and geology to identify which cave system offered the right acoustic properties for a temple, or which layer of rock could support a multi-level city? Their genius may have lain in observation and adaptation, recognizing that the earth already provided the blueprints and even the tools if one only knew where to look. This reveals a forgotten layer of ancient engineering, one based not on brute force but on a deep, symbiotic wisdom. The layout of these deep chambers speaks of a mind that saw the project in its entirety long before the first stone was ever struck. This was not haphazard digging, it was a form of applied geometry carved into the living rock. In the Hypogeum of Malta, the symmetry is deliberate, with chambers and passages aligned along precise axes. This level of order suggests the builders worked from a master plan, a mental or perhaps even physical blueprint that guided generations of hands. Imagine the tools of that planning stage, simple yet profoundly effective. A length of string dipped in ochre could be snapped against a wall to mark a perfectly straight line. A weighted plumb bob would ensure every wall was vertical, a critical necessity for structural integrity deep underground. They likely used basic geometric ratios, perhaps derived from the human form or celestial observations, to proportion their sacred spaces, ensuring harmony and balance in a world of utter darkness. The question then becomes, how was this intricate plan preserved and communicated across decades or even centuries of construction? In a time before widespread literacy, the answer may lie in the power of oral tradition. A dedicated class of master builders, guardians of the sacred geometry, would have verbally transmitted the complex instructions to their apprentices. This was not just a building technique, it was a living knowledge, a secret science passed from one generation to the next, ensuring that the vision for the underground sanctuary remained consistent and true. This challenges our modern assumption that such sophisticated planning requires written documents and digital models. It reveals a different kind of intelligence, one rooted in memory, ritual, and an unbroken chain of teaching. The evidence left in the stone compels us to ask, what does this level of foresight and organization tell us about the society that orchestrated it? Coordinating a workforce to execute such a grand, multi-generational vision points to a social structure far more complex than we often attribute to ancient cultures. The sheer scale of these underground worlds forces us to look beyond the individual artisan and consider the immense social machine required to bring them into being. This was not the work of a few determined families, but of entire societies mobilized for a common goal. To carve a city like Derinkuyu or a temple like the Hypogeum required a labor force numbering in the thousands, working in coordinated shifts across generations. How did ancient societies manage such colossal, long-term projects? We find clues in the worker villages near the Valley of the Kings in Egypt, where state-sponsored gangs of laborers were housed, fed, and supplied, their lives dedicated to the pharaoh's eternal resting place. This level of organization suggests a powerful central authority or a deeply ingrained communal tradition capable of marshalling resources and human energy for decades, even centuries. The motivation behind such an investment must have been profound. Was it the unifying power of a shared faith, compelling a community to build a sacred space for the divine? Was it the desperate need for a secure refuge, a project so vital to survival that every able hand was called to contribute? Or was it the economic drive of resource extraction, as seen in the Wieliczka salt mine, where the reward was a substance as valuable as currency? The choice to pour generations of effort into the earth speaks to a societal identity deeply intertwined with the subterranean world. These were not peripheral projects, they were central to the community's very existence, its safety, its spirituality, and its economy. The workers who swung the hammers and hauled the baskets were not slaves to a random task, they were participants in a grand, multi-generational story, building a legacy of security and meaning that would outlive them all. This incredible social coordination hints at a level of ancient sophistication we are only beginning to appreciate, compelling us to ask what other profound truths about our past might still be hidden in plain sight, waiting just beneath the surface. The drive to build deep was often fueled by something more than survival, a profound spiritual impulse that saw the earth itself as a sacred gateway. For countless cultures, descending into the ground was not a retreat from the world, but a deliberate journey toward the divine. These chambers became places of ritual, burial, and initiation, where the very depth was a physical manifestation of a connection to the underworld, to ancestors, or to powerful earth deities. In Malta's Hypogeum, this spiritual architecture reaches its peak. The complex is not a random collection of rooms, but a carefully orchestrated landscape. Its deepest chambers, like the Holy of Holies, are precisely aligned so that on specific days of the year, the light from the winter solstice sun would pierce through an opening, illuminating the central space in a dramatic play of light and shadow. This was not a coincidence, it was a built-in celestial calendar, a way to harmonize the rhythms of the human world with the cosmos above and the earth below. The depth of the Hypogeum, therefore, was not just a matter of digging, it was a cosmological statement. It placed the community's most sacred ceremonies at a point where earthly energies and celestial events were believed to converge. This worldview was not confined to the Mediterranean. Far across the Atlantic, the Maya of Mesoamerica held a similar reverence for the subterranean world. They saw natural sinkholes known as cenotes as portals to the realm of the gods, particularly the rain deity Chok. These were not just water sources, they were sacred sites of communication. Rituals and offerings, including objects of great value and sometimes even individuals, were committed to these deep, watery wells as a way to appease the gods and ensure the balance of the world. The choice of a cenote for such a ceremony was everything, its depth and inaccessibility amplifying its power as a conduit to the divine. How did these powerful spiritual beliefs directly shape the engineering? The motivation was everything. When a society believes it is building a portal to the gods, the technical challenges become spiritual tests to be overcome. The precise orientation of a chamber to catch the solstice light requires not just a surveyor's skill, but an astronomer priest's vision. The act of carving a stable, deep shaft into a cenote is not just about excavation, but about creating a perfect, stable vessel for divine interaction. The immense collective effort needed for such projects was likely sustained by a shared faith, a conviction that they were participating in a work of cosmic importance. The stones they moved were not just rock, they were the building blocks of their relationship with the universe. This fusion of faith and engineering may be the most powerful tool we have yet to consider, one that could inspire people to achieve what seems, from our modern perspective, almost impossible. The instinct to hide from danger runs deep in our species, but some communities transformed that instinct into a stunning architectural achievement. When faced with the threat of invasion or environmental hardship, the solution was not just to dig a hole, but to construct a complete, self-sufficient world beneath the surface. These were not temporary bolt holes, but long-term survival systems. Derinkuyu's design is a masterclass in defensive thinking. Its massive, rolling stone doors could isolate entire levels, creating a series of choke points against any pursuer. Inside, the city contained everything needed for a prolonged siege, from deep wells tapping into the water table to vast, cool chambers for storing grain and preserving food. This was a fortress designed to be occupied for months, a testament to the foresight born from repeated conflict. Across the continent in medieval Europe, the underground city of Naours served a similar purpose. Historical accounts tell of local populations vanishing from the surface during times of war, only to emerge weeks or months later from hidden entrances, their homes and livelihoods preserved intact. The depth of these refuges was their greatest asset, providing a buffer against the chaos above, whether from marching armies or the devastation of a raided village. How did the urgency of survival accelerate innovation? When your life depends on a secure space, problem-solving becomes immediate and non-negotiable. The need for fresh air at great depth led to the invention of sophisticated ventilation shafts. The requirement to conceal your presence forced innovations in camouflage and structural engineering to prevent cave-ins that would betray your location. This relentless pressure to survive likely compressed generations of architectural trial and error into a much shorter, more intense period of development. We learn from these structures that human resilience is not just about endurance, but about profound creativity under pressure. The communities that built them chose to invest immense collective effort into a hidden asset, a form of insurance policy carved in stone. They teach us that preparation itself is a form of hope, a quiet belief in a future worth securing, even when the present is shrouded in uncertainty. This practical drive to build for survival, however, stands in fascinating contrast to another powerful motivation, one that compelled people to dig deep not for safety from others, but for a connection to something far greater than themselves. The enduring stability of these deep chambers begins with a simple, brilliant choice: the selection of the right kind of stone. Ancient builders possessed a masterful, empirical understanding of geology long before the science had a name. They intuitively knew which rocks could be persuaded to hold a shape and which would crumble under pressure. They consistently sought out homogeneous layers, massive beds of stone free from the cracks and fault lines that would lead to collapse. The Wieliczka salt mine stands as a perfect testament to this. Salt rock, while demanding to excavate, has a unique plastic quality, meaning it slowly flows and compresses under pressure, naturally sealing small cracks and reinforcing the tunnels over time. This self-healing property is a key reason the mine's breathtaking chapels have remained intact for centuries. How did these early engineers acquire such specific knowledge without modern tools or textbooks? The answer lies in a deep, accumulated wisdom, a legacy of observation passed down through generations. It was likely a blend of careful trial and error and hard-won experience. A community would have learned from minor collapses in one area, noting the type of rock that failed, and then applied that lesson to future excavations. They learned to read the land for signs of stability, avoiding zones of seismic activity, and seeking out the massive, unbroken formations that promised safety. This was not random digging, it was a highly informed project management, a collaboration with the very bones of the earth. This profound expertise in site selection forces us to reconsider their relationship with the environment. They were not conquerors of the landscape, but its most attentive students, listening to its whispers and understanding its strengths. Their success was built upon this foundational partnership, a dialogue with the deep earth that we are only now beginning to fully appreciate. Breathing deep underground is a problem that cannot be solved by willpower alone. Without a constant supply of fresh air, even the most magnificent subterranean city would become a tomb within hours. This is where the engineering of Derinkuyu and similar sites moves from impressive to almost unbelievable. The solution they crafted was a network of ventilation shafts, narrow vertical chimneys that ran from the deepest chambers all the way to the surface, sometimes for hundreds of feet. These were not just simple holes. Their placement and design reveal a sophisticated understanding of a fundamental physical principle, that warm air rises. The living, breathing world below generated heat from people, animals, and cooking fires. This warm air would naturally ascend through these shafts, creating a gentle but constant suction that pulled stale air up and out, while simultaneously drawing cooler, fresh air down from the surface through other passages. It was a passive, self-regulating life support system, all powered by the simple physics of temperature difference. The challenge, of course, was in the execution. How do you ensure this delicate airflow persists across such a vast vertical distance? The answer lies in precision. The shafts had to be perfectly vertical, their surface openings carefully positioned away from obstructions to capture clean air, and their dimensions calculated to maintain the right flow rate. A shaft too wide might not create enough suction, while one too narrow could easily become blocked. This level of precision implies generations of observation and refinement. They may not have had the mathematical formulas of modern fluid dynamics, but they possessed something equally powerful: a deep, empirical wisdom born from watching how smoke behaves in a room, how a draft feels in a tunnel, and how the air changes with the seasons. They learned to listen to the breath of the mountain itself. This attention to health extended beyond just air. The constant circulation would have helped control humidity, preventing the damp, stagnant conditions where illness can thrive. It was a holistic approach to well-being, ensuring that a community could not only survive in the depths, but truly live there for extended periods. This mastery of an invisible force like air hints at a broader, more nuanced capability, one that becomes even more apparent when we consider how they conquered the equally formidable challenge of perpetual darkness. A reliable water source was the difference between a temporary shelter and a true underground home. Deep beneath the surface, the challenge was not just finding water, but accessing it without compromising the security of the entire complex. At Derinkuyu, the solution was carved directly into the city's foundation, deep wells that plunged straight down through multiple levels to tap into the pure water of the underground aquifer. This was not a matter of chance. The builders possessed a remarkable understanding of the land's hidden anatomy, knowing precisely where to dig to intersect these life-giving veins. They likely identified surface clues like specific types of vegetation or seasonal springs that hinted at the water flowing deep below. Once they began digging, the true test of their skill began. How did they prevent these deep, narrow shafts from collapsing in on themselves during construction? The answer lies in the same careful planning they applied to the city's rooms and tunnels. They would have reinforced the shaft walls as they descended, perhaps with timber cribbing or by lining the well with expertly fitted stones. This created a stable tube that protected the water source from contamination by surface runoff or from the debris of the city above. Every drop drawn from that well was a testament to their foresight, a vital resource secured through a blend of geological intuition and painstaking engineering. This mastery of water extended beyond Turkey. In the cooler, damper climate of Naours, the builders faced a different kind of water problem. Here, the constant seepage of groundwater through the chalky rock could have flooded passages and created a dangerously humid environment. Instead of fighting this moisture, they channeled it. They carved intricate networks of small trenches and basins directly into the floor, creating a managed drainage system that guided the water away from living areas and into dedicated cisterns for collection. This transformed a potential liability into a sustainable asset. The presence of these sophisticated hydraulic systems forces a difficult question. How did these cultures develop such a confident grasp of hydrogeology, the hidden behavior of water within the earth, without the tools we consider essential for such discovery? Their success suggests a long-term, intimate relationship with their local landscape, an accumulated wisdom gained from observing the land in every season over countless generations. They learned to read the silent language of the earth, understanding where water would gather and how it would move through different layers of rock. This knowledge turned the deepest, darkest chambers into habitable spaces, proving that their greatest tool was not made of metal or stone, but was a deep, living science of the earth itself. The silence within these stone chambers was never truly empty. It held a potential voice, a resonance waiting to be awakened by a single spoken word. This auditory dimension transforms a space from a mere shelter into a living instrument, and nowhere is this more evident than in the oracle room of Malta's Hypogeum. A low tone uttered here does not simply echo, it blooms. The sound vibrates through the rock, amplifying into a deep, pervasive hum that seems to emanate from the walls themselves, filling the entire chamber with an otherworldly presence. This is not a random acoustic fluke. The shape of the room, the curvature of the walls, and the specific frequency response were all carved with incredible intention. Researchers like acoustic engineer Dr. John D. have mapped these spaces and concluded that such precise sonic effects cannot be achieved by chance. The room was engineered to respond to the male voice in a very specific, powerful way. But what was its purpose? One compelling theory suggests it was a tool for spiritual ceremony. A priest or shaman's voice, transformed into something vast and seemingly non-human, could have been used to communicate with the divine or to guide communal rituals, blurring the line between the mortal world and the realm of the ancestors. The very air would have felt charged, the vibration a physical sensation that deepened the spiritual experience for all present. Yet there is another, more practical possibility. Sound can be a brilliant diagnostic tool. Before modern sensors, how did you test the structural integrity of a deep chamber you had just carved? You listened. A sharp tap or a sustained tone would reveal hidden cracks or unstable sections by the way the sound reflected or dampened. A clean, resonant ring might indicate solid, stable rock, while a dull thud could signal a dangerous fracture or a potential collapse point. The builders may have used their own voices and simple percussive sounds to literally listen to the health of the stone, turning acoustics into an early form of engineering safety check. This dual potential, both spiritual and practical, reveals a society with a highly developed sensory awareness. They were not just looking at their creation, they were listening to it. They understood that space is experienced not only with the eyes, but with the entire body. This mastery of sound challenges our perception of their capabilities, suggesting they possessed a holistic science that wove together physics, spirituality, and architecture into a single, seamless discipline. The mystery of how they carved these sonic wonders with simple tools remains, but the chambers themselves are not silent. They continue to whisper clues about a culture that heard the music in the stone and learned how to make it sing. These deep connections to the earth and sky converge in a breathtaking display of celestial engineering. Far from being isolated from the heavens, some of the most profound subterranean chambers were deliberately designed as astronomical instruments. The builders carved a relationship with the cosmos directly into the rock, creating spaces where the sun, moon, and stars became active participants in ritual and daily life. This is seen with stunning clarity at Newgrange in Ireland, a massive passage tomb constructed over 5,000 years ago. Its long, narrow entrance tunnel is aligned with the rising sun on the winter solstice. For a few precious minutes each year, a beam of sunlight pierces the darkness, traveling down the passage to illuminate the central burial chamber deep within the mound. This was not a lucky accident. It was a meticulously calculated event, a built-in promise of the sun's return at the year's darkest point. The depth of the chamber was essential to this drama. It created a long, light-proof corridor that transformed a simple sunrise into a focused, dramatic spectacle of rebirth and renewal. How did a Neolithic society achieve such precision without lenses or written records? The answer lies in generations of patient observation. They would have used simple sighting poles or marked stones on the horizon, noting the sun's extreme positions over decades to pinpoint the exact alignment. This celestial knowledge was likely a sacred science guarded and passed down by a spiritual elite. The cultural significance is profound. By linking a tomb deep within the earth to the cycle of the sun, they were weaving together life, death, and the cosmos into a single, unbroken story. The chamber was more than a resting place. It was a conduit between the world of the living, the realm of the ancestors, and the powers of the sky. This symbolic bridging of worlds is echoed far from the green hills of Ireland. In ancient Egypt, the subterranean corridors beneath certain pyramids and temples show alignments with specific stars, particularly those linked to their gods of the afterlife. The precise orientation of these deep shafts suggests the soul of the departed was believed to travel directly to the celestial realm. The depth of the structure, therefore, was not a barrier but a launch point, a symbolic representation of the journey from the earthly plane to the imperishable stars. This celestial aspect forces us to expand our definition of their tools. Their most crucial instruments were not just chisels and hammers, but wooden stakes, knotted cords for measurement, and most importantly, a deep, accumulated wisdom of the sky's clockwork. The alignment was everything. It transformed a dark, silent chamber into a place of profound expectation and connection, proving that their greatest architectural achievements were those that harmonized with the universe itself. The silent, perfect cuts in the stone pose a question that cannot be easily dismissed. When the tools we have found seem so mismatched with the results we see, it is natural to wonder if other, more advanced implements were once in play. This is the realm of speculative theories, ideas that venture beyond the standard archaeological narrative to propose lost technologies. Some researchers and authors, like Graham Hancock, suggest that a sophisticated civilization, perhaps one lost to a great cataclysm thousands of years ago, possessed engineering knowledge that later cultures only inherited and applied. The thinking goes that this forgotten society mastered techniques we are only now rediscovering. The theories put forward are as fascinating as they are controversial. Could they have used advanced drilling tools that left no trace, perhaps powered by a forgotten energy source? Some point to the legends found in cultures worldwide, stories that speak of sonic levitation, of using specific sound frequencies to make massive stones weightless and easy to move. While mainstream archaeology often views these ideas with deep skepticism, citing a lack of physical evidence, the tool paradox itself is the fuel that keeps this debate burning. How do we responsibly investigate such possibilities? The challenge lies in balancing open-minded inquiry with strict scientific rigor. We cannot simply accept every ancient legend as literal fact, but we also cannot ignore the persistent gaps in our understanding. The search for evidence is the critical next step. Are there any clues in the stonework itself that point to a technology beyond simple chisels? This controversial angle is not about proving a specific theory correct, but about acknowledging the depth of the mystery and encouraging a wider field of questions. It asks us to consider the full and perhaps forgotten scope of human innovation, yet the stones themselves hold a timeline we are still learning to read. To anchor these wonders in history, we turn to the science of archaeology, to methods like radiocarbon dating and stratigraphy. Radiocarbon dating measures the decay of a radioactive form of carbon in organic remains. A piece of charcoal from an ancient torch or a fragment of bone left behind in a deep chamber can be analyzed, giving us a window into the last time that material was part of the living world. Stratigraphy, the study of soil and debris layers, acts like a vertical timeline. In an excavation, the deepest layers are typically the oldest, with each successive layer above representing a more recent period. By carefully mapping these layers and the artifacts within them, archaeologists can build a sequence of occupation and use. These methods are powerful, but they are not infallible, especially in the complex environment of a subterranean site. A chamber carved in one era might be reused, cleaned out, or modified centuries later. This creates a palimpsest of human activity, where the evidence of the original builders is overlaid with the traces of those who came after. A compelling example of this complexity is found at the Ravna site in Serbia. Here, underground structures show clear signs of use across multiple distinct historical periods, from the Roman era to the medieval age. The dating evidence becomes a tangled web. How do we distinguish the moment of creation from centuries of subsequent habitation? The challenge is compounded by the simple fact that the archaeological record is profoundly incomplete. Organic materials, wooden tools, leather bags, food remains decay over time, especially in damp conditions. What survives is often the most durable stuff: stone, pottery, and occasionally metal. We are left with a collection of fragments, a partial picture where the most telling clues may have vanished long ago. This leads to a difficult but essential question. Could the original, foundational layers of these complexes be far older than the artifacts we find within them? If a site was meticulously maintained and cleared by later inhabitants, the evidence of its earliest creators might lie buried deep beneath the floor, or might have been removed entirely, leaving us with a timeline that only tells the last chapter of a much longer story. This shared architectural language echoes across the globe, from the American Southwest to the Scottish Highlands. The ancestral pueblones of the American Southwest constructed their kivas, circular, partially subterranean chambers used for ceremonies and community gatherings. These were not simple pits in the ground. They featured a sophisticated ventilation system, a small hole in the floor known as a sipapu, symbolizing the people's emergence from the underworld, and a carefully engineered airflow shaft that brought fresh air down into the enclosed space, preventing smoke from ceremonial fires from choking those inside. Across the Atlantic, in medieval Scotland, we find souterrains. These were stone-lined underground passages and chambers, often built beneath settlements. While their exact purpose is debated, many were likely secure storage spaces or temporary refuges, displaying a familiar understanding of how to create stable, hidden spaces within the earth. The parallel is striking. Societies with no known contact, separated by vast oceans and centuries, all arrived at a similar solution: the circular underground room. Why a circle? The shape is inherently strong, distributing pressure evenly and resisting collapse far better than a square or rectangular room. This was a practical discovery, a geometric truth learned through hard experience with the weight of the world above. The recurring need for ventilation is even more telling. Whether in a Turkish city or a Pueblo kiva, the fundamental human need for breathable air demanded a similar engineering response. This points not necessarily to a shared teacher, but to a shared set of problems. When faced with the universal challenges of structural stability and air supply, human ingenuity in isolation often converges on the same elegant answers. Does this mean these cultures were connected by some lost global traveler? It is a tantalizing thought, but the evidence more strongly suggests the power of independent innovation. When your survival depends on creating a safe space deep in the earth, you will inevitably discover the laws of physics and the principles of stable construction for yourself. The circle works, a ventilation shaft works. These are not secrets, but solutions waiting to be uncovered by anyone with the motivation to dig. This global pattern reveals something profound about our species. When confronted with environmental stress, whether the arid plains of Anatolia or the conflict-ridden landscapes of medieval Europe, or the need for sacred space in the deserts of North America, the response was often to go down. To seek sanctuary, meaning, and community within the enduring embrace of the earth. This collective impulse, this deep-rooted drive to build below, may be one of the most unifying threads in the entire human story, a silent testament to our shared resilience. The secrets of the ancient underground are no longer hidden in total darkness. Modern technology is now peeling back the layers of soil and rock to reveal a hidden world on an even grander scale than we ever suspected. Ground-penetrating radar, or GPR, works like a kind of X-ray vision for the Earth. By sending radio waves into the ground and measuring the signals that bounce back, it can map buried walls, voids, and tunnels without ever breaking the surface. This non-invasive approach has revolutionized archaeology. In Egypt's vast Saqqara necropolis, a sprawling city of the dead, recent GPR surveys have revealed a stunning truth. Beneath the sand lies not just a collection of isolated tombs, but an extensive, interconnected network of tunnels and chambers, a true underground labyrinth that archaeologists are only just beginning to comprehend. This discovery fundamentally reshapes our understanding of the site's scale and complexity. It suggests that the ancient engineers were not just building individual resting places, but were orchestrating a massive, organized subterranean landscape. But GPR is not the only tool illuminating these dark spaces. LiDAR, which uses lasers from an aircraft to map the ground surface with incredible precision, can detect the faintest impressions of forgotten entrances or collapsed shafts, even beneath dense forest canopies. This allows researchers to see the broader context of a site, how these underground complexes related to the world above. Once a promising void is located, 3D laser scanners are sent into the known chambers. These devices fire millions of laser points to create a perfect digital replica of the space, capturing every detail of the tool marks on the walls and the precise angles of the architecture. This digital record is invaluable, allowing experts to study the site long after they have left and to perform virtual tests on its structural integrity and acoustic properties. So what new mysteries are these tools uncovering? They are revealing that many known sites are far larger than their explored sections. A single chamber, long thought to be the end of the line, might be just an antechamber to a much deeper system that remains sealed and untouched. They are also finding evidence of advanced water management, with mapped channels and reservoirs that we never knew existed, showing a mastery of hydrology that kept these deep spaces dry and stable. Each new scan peels back another layer, inviting a profound reconsideration of ancient ambition. The Earth, it seems, has been keeping a secret history, one written not on parchment, but in vast, silent spaces waiting for the right moment to speak. These chambers have endured for thousands of years, a silent testament to a forgotten science of stability. Their longevity is no accident of nature, but the result of brilliant engineering choices carved directly into the rock. Look up in any of these vast halls, and you will often see the gentle curve of an arched ceiling. This shape is a masterpiece of structural logic, distributing the immense weight of the earth above down through the walls and out to the sides, instead of allowing it to press down on a flat, vulnerable surface. It is the same principle that allowed the Romans to build their aqueducts, a recognition that the arch is one of nature's strongest forms. But how did these early builders discover this without complex mathematical models? They learned from observation. They saw the natural arches in caves and understood their inherent strength. They noticed that a rounded opening in a stone wall did not crack like a square one. This was engineering born from a deep, empirical relationship with the physical world, a slow accumulation of knowledge passed from one generation of carvers to the next. This wisdom extended to the strategic placement of load-bearing pillars. These were not decorative columns, but essential supports left in place as the rock around them was carefully removed. The builders worked with the stone, not against it, identifying which sections of the living rock were critical to hold up the ceiling. In the vast stable areas of Derinkuyu, for instance, these pillars are positioned with clear purpose, creating a grid of support that has held firm for centuries. The layout of the rooms themselves reveals a sophisticated understanding of stress management. Builders avoided carving large chambers directly beneath one another, instead staggering them to prevent creating a single, weak vertical column of rock. Corridors were often offset, creating a labyrinth that naturally broke up and redirected the forces pressing down from above. What empirical rules did they follow? It was likely a system of proportions based on the human body and simple tools. A pillar's thickness might be determined by the arm span of the master builder. The height of a room might be limited to what they knew from experience the local rock could safely span. They possessed a tactile, intuitive feel for the limits of their material, a knowledge gained through trial and undoubtedly through the hard lessons of occasional failure. This ancient structural wisdom offers powerful lessons for our modern world, especially in the pursuit of sustainable architecture. We are now rediscovering the value of building with local materials and designing with natural forms that work in harmony with environmental forces, rather than fighting them with sheer concrete and steel. The passive ventilation and perfect temperature regulation of these underground cities are a blueprint for energy-efficient design. Their enduring stability, achieved with minimal environmental disruption, challenges our own disposable construction methods. These builders created legacies, not just shelters, reminding us that the most profound engineering is often about listening to the earth and understanding the timeless principles of balance and support. The silent evidence of these ancient chambers is a testament to success, but every triumph was likely built upon a foundation of unseen failures. The first time a ceiling cracked or a ventilation shaft failed to draw air, it was not the end of the project, but a critical lesson. This was not a process of flawless execution, but a long, generational conversation with the earth, where each mistake taught a new rule of survival. In the ancient copper mines of the Austrian Alps, we see this learning curve carved directly into the rock. Early mining tunnels are haphazard, following the rich ore veins without much thought for structural support. The inevitable collapses are visible in the archaeological record, marked by layers of debris and abandoned tools, but over centuries the methods evolved. Later tunnels show carefully shaped arches and the strategic placement of wooden support frames, a direct response to the hard-learned knowledge of what the mountain would and would not tolerate. How did a society process such a costly lesson? A collapse that claimed lives was a communal tragedy, but also a powerful, unforgettable piece of data. The survivors would have analyzed what went wrong, noting the type of rock that failed and the warning signs they missed. This was empirical engineering at its most raw, where the price of knowledge was immense. The preservation of this hard-won wisdom became a sacred duty. Before written records were common, this knowledge lived in oral tradition, passed from master builder to apprentice through stories, songs, and direct, hands-on instruction. An experienced miner could run a hand along a rock face and sense its stability, or listen to the echo in a shaft and know if the air was growing stale. This was a living library of practical science, where the memory of a past disaster in a specific type of stone could prevent a new one. This iterative process reveals a fundamental truth about our ancestors. Their progress was not a sudden leap, but a slow, cumulative climb. Each generation stood on the shoulders of the one before, inheriting not just successful techniques, but the crucial memory of what had failed. This relentless adaptation, this willingness to learn from the earth itself, may be the most powerful tool they ever possessed. These ancient legends speak of entire worlds hidden beneath our feet. Plato's account of Atlantis describes not just a lost island, but a series of concentric canals and a grand central citadel, engineering marvels that some researchers suggest could point to a sophisticated understanding of subterranean hydraulics and city planning. Far older still, the vast Hindu epics detail Patala, a luminous netherworld of 7 levels, filled with magnificent cities and advanced beings. While we cannot take these stories as literal history, they resonate with a profound cultural truth. Why would so many disparate cultures, with no contact between them, all choose the deep earth as the setting for their most powerful myths of origin and destiny? Perhaps these narratives are not mere fantasy, but the symbolic echo of a real and monumental past. They may preserve a collective memory of a time when humanity's greatest achievements were not towers reaching for the heavens, but cities and sanctuaries carved into the protective belly of the earth. The recurring theme of a hidden, advanced world below could be a way to immortalize the awe felt by later generations who discovered the ruins of these incredible underground complexes, structures so profound their construction seemed beyond human capability. The legends then become a kind of cultural container, safeguarding the memory of an engineering feat so grand that only the language of gods and heroes could do it justice. This blending of myth and possible history does not diminish the physical evidence, it enriches it, adding a layer of human meaning to the stone and mortar. It tells us that for our ancestors, going underground was not just a practical act of survival or resource gathering. It was a journey into the very heart of their identity, a descent into a realm where the physical and the spiritual were inextricably woven together. This environmental stability was a form of architectural genius. Deep beneath the surface, the Earth maintains a remarkably constant temperature, a phenomenon ancient builders learned to harness with stunning effectiveness. In the sun-scorched summers of Cappadocia, the surface world could become an oven, while winter brought a biting cold. Yet inside the underground city of Derinkuyu, the temperature remained in a comfortable range, around 55 degrees Fahrenheit, year-round. This was not a minor convenience, it was a revolutionary form of climate control that shaped every aspect of daily life. How did this thermal stability influence the society that relied on it? It meant food stores remained cool and preserved for far longer, reducing waste and ensuring a reliable supply through lean seasons. It provided a safe, temperate environment for the very young and the elderly, who are most vulnerable to temperature extremes. This consistent, sheltered world allowed for crafts like pottery and weaving to continue uninterrupted, regardless of the weather raging above ground. The society itself could plan its activities around a predictable, secure environment, fostering a stability that surface dwellings, at the mercy of the elements, could never guarantee. This ancient approach to passive cooling and heating holds profound lessons for our modern world, where energy-intensive air conditioning and heating systems strain both our resources and the planet. The principles are elegantly simple, using the Earth's own mass as a giant thermal battery to absorb heat in the summer and release it in the winter. Modern architects are now looking back to these designs, exploring Earth-sheltered homes and geothermal systems that mimic this ancient wisdom. The choice to go deep was not just about mystery or defense, it was a brilliant, sustainable adaptation to a challenging world, a reminder that some of the most advanced solutions are those that work in harmony with the planet itself. The human mind was never meant for a world of perpetual stone and shadow. Claustrophobia, the primal fear of enclosed spaces, must have been a constant, silent companion for those who carved their lives into the deep earth. Yet, these communities did more than just endure. They built cultures that flourished in the darkness. Their success hinged on brilliant psychological countermeasures woven directly into the fabric of their subterranean world. Architectural design itself was the first line of defense against the crushing weight of the rock. In Derinkuyu, corridors were not narrow, claustrophobic tubes. They were often wide enough for several people to walk abreast, and ceilings were carved high enough to prevent that looming, oppressive feeling. This deliberate sense of spaciousness, even hundreds of feet down, was a conscious act of mental preservation. Light, or the illusion of it, was another critical tool. While we know they used oil lamps and torches, the strategic placement of reflective surfaces could amplify their effect. A polished metal plate or a light-colored stone wall would catch and scatter the flickering flames, creating a dance of light and shadow that mimicked the dynamic quality of sunlight, fighting the sensory deprivation of a uniformly dark environment. But perhaps the most powerful tool was community itself. The very layout of these spaces fostered social connection. Communal kitchens, central plazas, and shared worship halls were not just practical, they were psychological necessities. These were places for storytelling, for shared meals, for the noise and warmth of human interaction that staves off the profound isolation of life underground. The rituals conducted in these halls, like the resonant chants in Malta's Hypogeum, would have created a powerful, shared emotional experience, binding individuals together and giving them a sense of purpose that transcended their physical circumstances. The art they left behind offers a profound glimpse into their inner world. The beautiful sculptures in the Wieliczka salt mine or the intricate red ochre spirals in the Hypogeum were not mere decoration. They were a declaration of identity and meaning, a way to imprint the human spirit onto an inhuman landscape. By creating beauty in the depths, they transformed a cavern from a mere hole in the ground into a place of belonging, a home. This deep understanding of the human psyche reveals that their greatest engineering triumph was not just the mastery of stone, but the mastery of the mind itself. How did they maintain this delicate balance between the physical need for shelter and the psychological need for light and connection? The answer lies not in their tools, but in their unwavering focus on creating a world worth living in, even when the sun was far above. Salt itself was a form of ancient currency, a substance so vital for preserving food and sustaining life that it could command immense wealth. This economic reality transformed the Wieliczka mine from a simple hole in the ground into a sprawling underground empire. The relentless demand for this white gold created a self-perpetuating cycle of innovation, where the profits from each ton of salt extracted were immediately reinvested into digging deeper and more efficiently. Wealth did not just fund the excavation, it actively drove the advancement of underground technology. As the miners followed the rich salt seams downward, they were forced to confront ever greater engineering challenges: the pressure of the rock, the management of groundwater, the need for stronger supports. Each new level demanded a new solution, and the financial returns ensured that those solutions could be developed and implemented. This was a pragmatic, profit-motivated laboratory where the pursuit of resources accelerated the development of safer tunneling methods, more effective drainage systems, and more durable structural supports. The mine's breathtaking chapels, carved from the very salt they sought, stand as a testament to this synergy. They were not just acts of faith, but also declarations of success, funded by the prosperity that depth itself had provided. This pattern repeats across the world. In the ancient turquoise mines of the Sinai Peninsula, Egyptian pharaohs dispatched massive, state-sponsored expeditions to dig deep tunnels into the mountains. The wealth generated from this prized mineral, used in exquisite jewelry and religious artifacts, justified the immense logistical effort and the development of sophisticated mining techniques that would later influence other construction projects. The drive for resources compelled cultures to push the boundaries of the possible, turning the dark, dangerous work of digging into a calculated investment. The deepest chambers, therefore, are not always monuments to gods or refuges from conflict. Some are the legacy of commerce, silent evidence that human ambition, when fueled by economic necessity, can literally move mountains. The very darkness of these chambers served a higher purpose, transforming them into perfect vessels for secrets. For certain spiritual groups and esoteric schools, the profound depth offered more than just security. It provided the ultimate secluded classroom, a space where sacred knowledge could be protected from the uninitiated. This need for absolute secrecy directly shaped the architecture of the underground. Entrances were not just hidden, they were often designed as tests of worthiness. A potential initiate might be led on a bewildering path, through a series of identical-looking tunnels or past cleverly concealed doors that blended seamlessly into the rock. Only those who knew the precise sequence of turns or the exact stone to press could gain access to the inner sanctum. This was security through obscurity, a physical puzzle guarding a spiritual truth. The layout itself reinforced the journey of enlightenment. Many of these spaces are designed as a progression, moving from larger, communal antechambers into smaller, more intimate rooms, and finally to a single, central chamber reserved for the most profound ceremonies. This architectural funnel mirrored the initiate's own path, moving from the outer world of everyday life into the inner world of esoteric understanding. The resonance of a place like Malta's Hypogeum takes on a new dimension in this context. The otherworldly echo in the oracle room was not just a spiritual effect, it was a practical tool. A master's teachings, amplified and distorted by the stone, would become impossible for any eavesdropper outside the chamber to understand, while simultaneously overwhelming the senses of those within, breaking down their ordinary perception to prepare them for a new reality. What traditions might have used these spaces? While definitive proof is elusive by the very nature of secrecy, historians note possible connections to early Gnostic sects who sought a direct personal knowledge of the divine, or to the mystery schools of the ancient Mediterranean, where rituals of death and rebirth were central to the initiate's experience. The deep earth was the perfect symbolic setting for such a ritual, representing both the tomb of the old self and the womb of a new, enlightened being. This aspect invites us to consider a hidden layer of history, one where the deepest wisdom was not written on scrolls, but encoded in the silent, enduring language of stone and space, preserved in the earth's embrace for those who knew how to listen. The mystery of these deep chambers cannot be solved by archaeology alone. It demands a conversation between disciplines, a fusion of different ways of seeing. On the Giza Plateau, this collaborative approach is revealing secrets long buried beneath the sand. Archaeologists map the cultural context, while geologists analyze the bedrock's composition and stability. Engineers model the structural forces at play, and physicists contribute with ground-penetrating radar and microgravimetry, techniques that detect hidden voids by measuring tiny changes in the Earth's density. Together, they are piecing together a three-dimensional blueprint of a subterranean world far more complex than any single field could perceive. This integrated perspective transforms a narrow question of how they dug into a broader investigation of why they built and how they sustained such ambitious projects. The true breakthrough lies at the intersection of these specialties, where a geologist's analysis of water channels confirms an archaeologist's theory about a site's spiritual significance, or an engineer's stress model explains why a specific pillar was left in place. This is how we begin to read the full story written in the stone. But this quest is not confined to academic institutions. A growing community of citizen scientists and independent researchers brings a powerful new dimension to the search. Equipped with increasingly accessible technology like drone photography and open-source mapping software, these passionate individuals often survey remote sites or analyze vast datasets that larger teams might overlook. Their fresh perspectives and dedicated observation have led to the identification of potential new entrances and previously unrecorded architectural features. How does this collective effort change the discovery process? It democratizes the mystery, inviting everyone who is curious to contribute a piece to the puzzle. This integrated, crowd-sourced approach promises to peel back the layers of the enigma one discovery at a time, reminding us that some of history's greatest secrets are too vast for any one group to unlock alone. The allure of these deep chambers often inspires grand theories, from ancient aliens to sunken super-civilizations. Yet the most compelling story is not about visitors from the stars, but the extraordinary potential of people right here on Earth. Separating fact from fiction requires a careful look at the evidence we actually have. Mainstream archaeology does not dismiss these wonders, but it grounds their explanation in human skill, patience, and a deep, accumulated knowledge of the natural world. The idea that our ancestors were incapable of such feats with simple tools is a modern bias, one that underestimates the power of generational effort and specialized understanding. Imagine a project not as a single lifetime's work, but as a legacy, a mission passed from parent to child for hundreds of years. What seems impossible to accomplish in a decade becomes achievable over 20 generations, with each one building upon the lessons of the last. Responsible discussion means celebrating this human ingenuity without needing to invent outside intervention. The true wonder is not that aliens might have built these places, but that humans did, using their intellect to solve profound challenges of engineering, logistics, and survival. This perspective does not diminish the mystery, it elevates it, transforming the narrative from a search for lost gods to a profound appreciation for our own species' forgotten capabilities. The stones themselves tell a story of triumph, a testament to what communities can achieve when united by a common purpose and an unwavering connection to their world. The next chapter of this story is already being written with tools that listen to the Earth's silent whispers. Ground-penetrating radar and advanced seismic sensors are now revealing anomalies that hint at entire undiscovered levels beneath known sites, suggesting our current maps are merely sketches of a much grander reality. One of the most tantalizing puzzles lies near the town of Visoko in Bosnia, where the so-called Pyramid of the Sun site features a complex network of underground tunnels. The purpose of these stone-lined passages remains fiercely debated by researchers. Some propose they are ancient energy conduits or sacred pathways, while others suggest more practical functions like ventilation or water channels. Unraveling this mystery without damaging the site represents the cutting edge of modern archaeological practice. As our ability to peer through stone improves, we face profound ethical questions. How do we balance the human urge to uncover secrets with the responsibility to preserve these fragile time capsules? Every time we break a seal or introduce modern air into a chamber sealed for millennia, we risk altering its delicate environmental balance, potentially destroying clues that future, even more advanced technologies could read. The goal is shifting from excavation to conservation, from digging to detailed digital preservation. By creating perfect three-dimensional virtual models, we can offer access to everyone while leaving the physical site undisturbed for the generations that follow, who will surely have tools and questions we cannot yet conceive. This careful, respectful approach ensures that the deepest chambers will continue to guard their secrets until we are truly ready to understand them, promising that the final word on our ancient past has not yet been spoken. These silent stone cities force a difficult but thrilling question. Have we fundamentally misunderstood the timeline of human innovation? Our standard history books often present a neat, upward-sloping line from simple stone tools to complex machinery, implying that older must mean more primitive. Yet the evidence carved into the bedrock of Turkey, Malta, and countless other sites presents a stark contradiction to this comfortable narrative. Here we find achievements of engineering, logistics, and social organization that rival, and in some ways surpass, what we might expect from their era. This does not mean they had our technology, but rather that they possessed a different kind of sophistication, one born from a deep, intimate partnership with their environment. Their progress was not linear, but a series of brilliant, context-specific solutions to the challenges of survival, spirituality, and community. Some of this hard-won knowledge was undoubtedly lost, only to be rediscovered centuries later. This realization invites a profound sense of humility. We are not the first to grapple with the fundamental problems of how to build a stable society, how to manage resources, or how to create meaning. These ancient builders remind us that human capability is not a single path, but a vast and varied landscape of potential. Their legacy, hidden in plain sight beneath our feet, challenges us to look at the past not as a simple prelude to our own time, but as a rich tapestry of experiments in living, each with its own unique wisdom to offer. Perhaps the greatest mystery is not how they built these chambers, but what their existence says about the cyclical, rather than linear, nature of discovery itself. This journey into the Earth's hidden chambers does not truly end when the video does. It continues within your own sense of wonder. These ancient spaces challenge us to look at the world and at history itself with a more curious eye. Perhaps they inspire you to question the stories we have been told about our past, to seek out the hidden layers in your own local landscape, or simply to learn a forgotten skill from your own heritage. The true legacy of these builders is not just in the stone they carved, but in the spark of inspiration they leave with us today. We would love to hear which of these subterranean sites captures your imagination the most. Does the sheer scale of Derinkuyu leave you in awe, or does the sacred echo of Malta's Hypogeum stir something deeper? Share your thoughts and discoveries in the comments below. Your unique perspective adds a vital voice to this unfolding story, reminding us that history is not a closed book, but a living conversation we all participate in, one revelation at a time. We have traveled from the sunken sanctuaries of Malta to the vast refuge cities of Turkey, each one a monument carved not just from stone, but from a profound and shared human need. These deep chambers are far more than ancient ruins. They are enduring symbols of our species' relentless ingenuity. They speak of a drive to find safety from conflict, to seek connection with the divine, and to create lasting community in the most unlikely of places. While the full story of their construction may still hold its secrets, each new piece of evidence brings us closer to a humbling truth. Our ancestors possessed a formidable understanding of their world, a deep earth wisdom that we are only now relearning. Let this journey remind you that history is filled with quiet revolutions, with achievements that defy our simplest assumptions. The next time you walk on solid ground, remember the hidden worlds that might lie just beneath your feet, and consider the extraordinary lengths people will go to in order to build something that endures. Thank you for exploring these depths with me. If you are curious to uncover more stories that challenge the ordinary, subscribe and join the next exploration into our forgotten past.